Speed, v equals d over t. How fast something moves. Distance traveled divided by the time taken. Watch the car cover distance against time. That rate is speed. Acceleration, A equals delta v over t. How quickly velocity changes. Speeding up, slowing down, or changing direction all count as acceleration. See the object speed up. Velocity is changing, so there is acceleration. Force, Newton's second law. F equals ma. Net force equals mass times acceleration. A larger force, or a smaller mass, gives a bigger acceleration. Same push, light mass moves farther. Force equals mass times acceleration. Weight, W equals mg. The gravitational force on a mass on Earth g approximately equals 9.81 meters per square second, so weight is mass times g. The scale reads weight, the gravitational force on the mass. Work, W equals Fd. Energy transferred when a force moves an object through a distance in the direction of the force. Lift the box through a height. Force times distance is work. Power, P equals W over T. The rate of doing work, how quickly energy is transferred. Same work done faster means higher power. Same work, faster lift means more power. Kinetic energy, Ke equals 1/2 mv squared. Energy of motion, doubling speed multiplies kinetic energy by 4 because of the v squared. A bouncing moving mass carries kinetic energy. Gravitational potential energy, Pe equals mgh. Stored energy due to height in a gravitational field. Raise an object and you increase P. Higher means more gravitational potential energy. Momentum, P equals mv. Mass in motion. In collisions, total momentum is conserved if no external forces act. Colliding masses share momentum. Impulse, F delta t equals delta p. A force applied over time changes momentum. Crumple zones lengthen delta t to reduce peak force in collisions. Longer contact time softens the peak force for the same momentum change. Hooke's law, F equals kx. Spring force is proportional to extension, within elastic limit. Stiffer springs have larger K. The spring stretches. Force is proportional to extension. Density, ρ equals m over v. How tightly mass is packed into a volume. Objects denser than the fluid tend to sink. Denser objects sink, less dense ones float. Pressure, P equals F over A. Force spread over area. Same force on a smaller area means higher pressure, sharp versus blunt. A sharp tip has small area, so pressure is high. Heat energy, sensible heat. Q equals mc delta T. Heat needed to change temperature. More mass or larger temperature rise needs more energy. C is specific heat capacity. Heat flows in and temperature rises. Latent heat, Q equals mL. Energy to change state without temperature change, melting, boiling. L is specific latent heat. During melting, temperature stays flat while latent heat is absorbed. Boyle's law, P1 V1 equals P2 V2. At fixed temperature, pressure and volume are inversely proportional for a fixed mass of gas. Squeeze the piston, volume down, pressure up at fixed temperature. Ideal gas law, PV equals nRT. Links pressure, volume, amount of gas, and absolute temperature for an ideal gas. Ideal gas, pressure, volume, moles and absolute temperature are linked. Wave speed, V equals F lambda. Wave speed equals frequency times wavelength. The wave travels, frequency times wavelength is wave speed. Frequency, F equals 1 over T. How many cycles happen each second? Period T is the time for one full cycle. Faster oscillation means higher frequency and shorter period. Snell's law, N equals sine I over sine R. Refraction, the ratio of sines of angle of incidence and refraction equals the refractive index. Light bends at the boundary, Snell's law. Ohm's law, V equals IR. Voltage across a resistor equals current times resistance. Current flows through resistance, voltage equals I times R. Electrical power, P equals VI. Electrical power is voltage times current. Also P equals I squared R and P equals V squared, R for ohmic resistors. More electrical power makes the bulb brighter. EMF and internal resistance. Epsilon equals V plus IR. Terminal voltage plus lost volts, IR, equals the cells E, M, F. Real batteries have internal resistance R. Real cells lose volts across internal resistance. Motor force, F equals BIL. Force on a current-carrying conductor in a magnetic field, when field-up tack wire. Basis of electric motors. A current wire in a magnetic field feels a motor force. Mass-energy equivalence, E equals mc squared. Mass and energy are interchangeable. Even a tiny mass stores enormous energy because c squared is huge. A tiny mass can store huge energy. Half-life, N equals n0 times 1/2 to the power T over half-life. Activity or number of undecayed nuclei halves every half-life T 1/2. Used in dating and safety. The count halves every half-life. Newton's law of gravitation, F equals gm 1 meter 2 over r squared. Every mass attracts every other mass. Force falls with the square of separation. Two masses attract. Force falls with distance squared. Gravitational field strength, G equals gm over r squared. Field strength at distance r from mass m near Earth's surface G approximately equals 9.81 N, kilogram. Gravitational field weakens farther from mass m.